Mic test, mic test. Okay, we are live. Um, yeah. Let me. Okay, so I'm quite cooked for this mod. I'm gonna, I'm gonna try to go through this 100 plus pages of 150 pages of notes today. It's the first time I'm seeing this set of notes. Yeah, hopefully it goes well. Okay, so okay, so okay, so where do we begin? Okay, I think let's begin by talk about sampling. I think one thing I definitely need to study is the various kinds of sampling. So you look at chapter 1 solutions. There is quite a lot to um, yeah, there's quite a lot to memorize. Like, let's see if what is stratified sampling. Yeah, okay, so something like that. I need to study all the different types of sampling. So you know what, I'm just gonna, for sake of completeness, I'm just gonna go through everything. So data, blah blah blah. Population is the entire group. Research question, blah blah blah. Okay, some research questions. Okay, so narrowness of the research question. Focus, simple or complex. Okay, data analysis. Sampling, population parameter is the actual characteristic of the population. Census is an attempt to reach the entire. Okay, but we cannot have census, right? So it's good to have sometimes it's good enough to have a sample, so you can estimate the population parameter, right? Okay, sampling frame is a list from which the sample was obtained. So what does that mean? Sense Sampling frame is the list from which the sample was obtained. Okay, note that since census does not involve sampling, the notion of sampling frame is not applicable in this context. I do not know what that means, but it's okay. Okay, so let's study the various type of biases, right? So blah 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 blah. Okay, one of the concepts is generalizability. Generalize the findings. Okay, so the concept of generalizability. Must try to avoid bias. What kind of bias is there? Selection bias, non-response bias. So selection bias is when it's an imperfect sampling frame, which excludes unit. Okay. So it can be solved using non-probability sampling. Okay, so that's something we need to study later. Non-response bias is when non-disclosure. Okay, sure, unwillingness, blah blah. So non-response bias may occur regardless of whether it's probabilistic or non-probabilistic nature. Okay, some examples. Let's skip that in the interest of time. Okay, so there's I guess sampling that splits into two, right? There's either probability sampling or non-probability sampling. For probability sampling, there's a few types. There's four main types. There's simple random sampling, which is units selected randomly from sample, size of n, sampling without replacement. So yeah, I use an RNG. Okay, then the systematic sampling, which means that selecting units from a list by applying a selection interval k and a random starting point from that first interval. Okay, sure. Okay, sure, that kind of makes sense. Okay, sure. That sounds good. So for example, k is 10, then we sample this. Compared to this, it's simpler sampling process, so we do not need to know. So what is sampling units? I don't really understand this line. Yeah, what does this line mean? What is sampling unit? Denoted P. Oh, sampling unit is the size of the sampling frame. Ah, okay. Okay, welcome to the stream. Okay, so okay, right. So 110. So basically sampling unit is number of items in the sampling frame, I believe. Stratified sampling is something that always confuses me. Where the sampling frame is divided into groups called strata, and they share similar characteristics. But the size of each stratum doesn't have to be necessarily the same. We apply simple random sampling to each stratum. Okay, so I think it's like grouping into small groups and picking one from each group, right? I think. Yeah, last one is cluster. So let me see the answer here. So a researcher wishes to study procrastination and blah blah blah. 100 sample 100 students. He rolled a dice and then a tree. Okay, so this is clearly what's it called? The interval thingy. What's it called? Systematic sampling. Yeah. Okay. So this is. Wait. What? What is answer C? He picked the third student. Okay. Even though the tree was chosen randomly, fair die. The 7th to 10th has a non-zero chance of being okay. Okay, so they're saying that this is non-probability. I'm a bit confused actually. Wow, there's a. Well, yeah, I'm kind of confused why this is non-probability. Yeah, isn't this still under probability sampling? Isn't that exactly what this is? Yeah, I'm kind of confused here. Um, I see, I see. Okay, it's by the fact that he's doing a plus 10, right? By the fact that he's doing a plus 10 each time. That's why the rest have no chance. Okay, that's tricky. Yeah, are there other instances of... Okay, let's see. A population of 200 secondary school students that I wish to take a sample from. Among the students, there are blah 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 in the name list. Number students numbered from... Okay. Okay, so in scenario 1, 50 numbers are being generated randomly. Okay, so this is I think scenario 1 should be simple random sampling, right? SRS. Scenario 2, okay, it's a multiple choice option. So number 1 is I think is simple random. Number 2, a fair dice is thrown. If it shows 1 or 2, then students whose last name starts with A to I are included in sample, while the rest are not. 3 to 4, so on. That sounds a bit like clustered to me. Cluster sampling is divided into clusters. A fixed number, all units, right? All units, yeah, okay, so that sounds like cluster sampling to me. And last scenario, that sounds like cluster sampling to me. No, okay, the answer is non-probability, right? So yeah, there's no deliberate use of chance, right? So that's what it means. Okay, and this one, let's see this one. So they're in an examination hall that has how many rows and how many chairs in each row. The numbered women sit in chairs. Okay, so this is kind of like a clustering of sorts, but which of the following will not produce a simple random? Okay, so choose a random row, select all. So that's kind of like systematic sampling, right? That's kind of yeah, okay. But we want a simple random one. So I think A is because we want something that's not. So I think this is first one should be simple, should be systematic sampling. If K equals to 1, second one, okay, this one does that one that is SRS, right? Third one, so this one sounds to me like a stratified sampling. So maybe this one. Last one, select letter from the English alphabet randomly. That sounds like clustered sampling to me. Okay, so A is not SRS since every group of size 16 has the same chance of being selected. Yeah, okay, that makes sense. B is a SRS, C is a... Oh, okay, so I guess to find SRS means that every person has a same chance, right? Whereas something that's not SRS, you must find some kind of some like statement, like some kind of group. has the same chance. Okay. Yeah, okay. I think yeah, okay, sure. Okay, so simple random sampling. Stratified sampling, blah blah blah. I wonder if that's in the cheat sheet that I have. I'll check later. Okay, so categorical variables, numerical variables. Okay, mean, statistic deviation, standard deviation. Sample variance is divided by n minus 1. Okay, that's interesting. Coefficient of variation, median, quartiles. Okay, that's a bit tough. Random assignment, what does that mean? Okay, so that's treatment and control, right? Random assignment. Okay, I guess we can look through chapter 1. I can look through chapter 1 stuff. Just try to speed through it. Okay, so new drug. How many patients to group A? Okay. Okay, random assignment. Okay, yeah, so this is false, right? Because you are randomly allocating participants to each of the groups. So okay, so I think this is probably C. Yeah, placebo is a substance that has no effect. Okay. Probably just gonna do 5 questions and move on. Um, Hello, hi ABMX, welcome. Thanks, welcome to the stream. Yeah, sorry, this is a bit of a boring stream. It's just me trying to revise. Uh, okay, so I'm kind of phasing out over here. It's kind of tiring. But oh well. So researchers want to test the effectiveness of drug Y. There's 2,000 subjects over here. Random assignment is equal. Okay. Okay, how many young females are we expect to see in the treatment group? Okay, so I suppose the answer is probably just 700 out of 2000. Is it just 700 out of 2000 times? Okay, yeah, so it's just 7,000 out of 700 out of 2000, which is 3.5, 35%. 35% of 1200, 35% of that, is it 7, can't really do math now. We do the multiplication, 6, yeah, okay, yeah, that's 420, okay, so that's just a bit of math. Large scale experiment, a researcher randomly assigns 6,000 subjects to receive either a drug or placebo. 4,000 will receive the drug and 2,000 placebo. The quick head count. This amount of males receiving the drug. You don't have to do a head count of placebo group. But the most reasonable number would be probably something like 75% of this, right? So we want 500. Yeah, because random assignment 10 to blah blah blah. Okay, let's do the last question. Let's probably try to do the last question in this. Okay, so virus X has been known to blah blah blah. Your following statements are true. Random sampling should be done to ensure that the subject's demographics are similar. Yeah, so it's not random sampling, right? Random assignment. Blinding researchers to subject assigned groups is important because researchers. That's kind of weird. I don't know why it's true. Why is blinding researchers? Oh, I guess so. This is false, right? Because yeah, it doesn't matter if I ungroup equal group sizes. Okay, so they're gonna move on to chapter 2. Let's try to move on to chapter 2. Categorical data analysis. Okay, so the two main type of variables, blah blah. Okay, so it's ordinal and nominal. Ordinal are those that come with natural ordering. Nominal is there's no intrinsic. Numerical variables there's continuous or discrete. Yeah, so Okay. So the outcome of the treatment is a nominal because there's no ordering, right? There's no ordering of success or failure. Blah 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 blah. So you calculate the rate, right? So calculate the rate. Yeah, I'm a bit more familiar with the rate stuff. I spent a bit of time looking through rate stuff and positively associate, negatively associate stuff. So I think this part is probably okay. I think the important thing to note over here is that the things that you're always comparing is always the second place, right? Like rate of x over x given something versus rate of x given something else. The first thing always stays the same, right? If you notice, like NA and NA, and I think beyond that, other than that, it's quite intuitive. Yeah, it's a lot of English right now. All these symbols don't really make sense, but when it comes down to it, it's kind of intuitive. When I can prove all these rules, blah 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 blah. So yeah, all this stuff is probably okay. Let's see, GA chapter 2 solutions. Okay, so let's once again do 5 random questions, right? Random sampling. Let's do question 11. News station conducted a survey to find political blah blah. Okay, so favor or not favor. So rate, you sum up the entire all the stuff. Yeah, in this case it seems clear that not favor is the one with the higher rate. So A is clearly true, so it's not incorrect. Liberal versus conservative, seems like this is true also. Male and favor 150. Male and not favor is higher, so I think this true also. Lastly, female and conservative, I think this is quite easy, right? Let's choose another random one. Okay, actually, you know what? I'm gonna scroll through. To look for keywords that I do not know. I think this chapter is probably a bit more okay. Then after that, I'm gonna go through the group chat, right? The Telegram group chat. Yeah, it's a bit too wordy for my liking. Alright, let's revise a bit about the Simpson paradox stuff. Yeah, so the Simpson paradox thing goes something like phenomena where a trend appears in more than half of the groups of data but disappears when groups are combined. Okay, confounders might not necessarily to the Simpson paradox. Simpson paradox needs a confounder, but confounder doesn't always lead to Simpson paradox. Um, observational study can be conducted when unable to assign to. Okay, I guess where did they study that? Randomized assignments will always result in equal allocation. No, that's not true. Okay, this looks like a boring chapter. I'm gonna skip this chapter. Dealing with numerical data. Okay, symmetric distribution, mean, median, mode, 3 possible shapes. Okay, that's good. We usually have something like that. Okay, variance. I need to learn how to read box plots. Box plots or univariate. Okay. Okay, so there's a box from Q1 to Q3. Outliers are ignored. And the min and the max, right? The smallest value is not an outlier. Largest value is not. The whisker represents the min and the max. So okay, I think that kind of makes sense. Outliers are probably in dots. Okay. Bivariate data, scatter plot. Okay. Quadratic, linear, exponential, blah blah blah. Stronger, weaker relationship. Correlation coefficient. Sign tells us the direction. If it's positive, then it's positive association. If it's negative, then it's negative association. When all the variables increase, the other tends to decrease, blah blah. 1 is perfect, right? -1 is perfect negative association. 0 is no linear association. Okay, sure. So just because there's no linear association doesn't mean there is no association. This is a spectrum of strong, medium, moderate, or weak. Cutoff is 0.3 and 0.7. Correlation is not affected by changing the xy variables or by an offset or by a scaling, because it doesn't really change linear relationships, right? So yeah. Okay, sure. Hi, welcome to the stream. Yeah, okay, so that's that. Linear regression is used to sum of square errors. Okay, so let's take a look at exercise 3. Okay, so which of the following statements must be true about the scores given below? So I suppose L and H. L and H are here. The median score is 70, so well, we need to sort it, right? Sort it in order, and something like that. And we do see that median is okay. There's only one mode amongst them. 70 is a mode, but there is entire possibility that there could be two modes, right? Range is greater than 35. What is range? Range is the highest minus the lowest. That's the highest minus the lowest. Oh yeah, okay, the highest minus the lowest. Mean score is greater than this. We can assume the worst case and do something there. Just pick a random question and do it. Scatter plot. Maximum mark for exam is this. After removing outlier, which is this one, strength of linear relationship will increase. Yeah, that's generally true, I think. A is true. After removing outlier, the correlation coefficient will increase. Why is that not true? Oh, correlation coefficient will go close, would decrease and go closer to -1, so that's false. Higher absenteeism rate causes, right? Causes is not as a correlation, not causation. Linear regression is failure data, the grade, no, yeah, okay, that's clearly true. Let's choose another random question. Consider I'll do one with a box plot. Yeah, after this question I'll do one with a box plot. The correlation after the outliers are removed. Okay, so this once again similar in nature, right? This one will increase, not really, because G, yes, I think it's true. Correlation will decrease. Previously, this looks kind of uncorrelated, right? Removing outliers always so I think I need to study what happens to Okay, so sorry, I'm back. Just need to reply some messages. Okay, where were we? I think I need to understand what happens when outliers are removed. An outlier is okay. So what happens when we remove outliers? What happens when we remove outliers? What will happen? Yeah, okay, I'm keen in seeing how it will affect the... Maybe I should ask ChatGPT. How do outliers affect correlation coefficient? Okay, sure. So, yeah, okay, I can see kind of what they mean now. Removing will bring it closer to 0. Okay, let's find one with a box plot, yeah? Let's find one with a box plot. Okay, yeah, this one is a box plot. Should have 2 marks more. So the correct median score, what is X? So X the mean. Is it 79? The new IQR should remain the same, right? So it's still the same as 82 minus 66.20. Yeah, so that remains the same. Okay, sure. So I think, yeah, I think that kind of makes sense. Okay, sure. So, kind of tired. I'm gonna stop chapter 3 and go to chapter 4. Oh, did I accidentally reorder the pages? Whatever. Chapter 4, inference. Blah blah blah. Blah blah blah. Blah blah blah. Yeah, okay, so conditional probability and independence. Okay, Bayesian stuff. Okay. Okay, that makes sense.
Hey,
Hey,
studying
yeah,
Oh, I give up already, bro.
I'm streaming.
Oh shit.
Oh, I hit a peak in viewership. Let's
Oh.
go. Come, say hi, say hi.
Oh, it's okay, it's okay.
No, it's okay, study together.
Wait,
Come,
what
sit
you
on my
doing?
bed, sit on my bed.
Oh, which question you doing?
Just looking through the notes.
Bro, oh, you. Oh, their notes.
Yeah. The on canvas. I don't know, it's the first time I look at it also.
You print out your cheat sheet already?
Haven't eh.
I
Yeah,
got
print out together.
But later I going down lah.
Okay,
We go out
okay.
together after you're done.
Can.
But I give up already, sir.
Why?
I do the
That's SU
when I do the exemplify practice paper, I get everything wrong, bro.
That's SU it's
I don't
okay.
get SU. You don't get SU, right?
My SU see how. My group project wasn't too good.
Oh. Just need to get D plus, bro. D plus can SU, right?
D?
Yeah.
D can SU, yeah.
Oh, bro, then.
Okay, it's fine
Okay,
Can. Okay, when I go down print, I call you
okay, what time you going now?
10:30.
Okay, I started before.
Okay. Yeah, that was my friend. I think I should probably study for stats too at the same time. Actually, you know what? I'm gonna change this stream name to ST2334. Try to put in some time for stats too. Yeah, no. Let's go to the questions. I'm kind of okay. Conjunction fallacy, base rate. Wow. Okay, let's read that. I actually need to study that. Law of total probability. Start with an example. Okay, conditional probability. Blah 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 blah. Law of total probability states that EFG. This then G is okay. That kind of makes sense. They talk a lot about this Sadie Clark thing. Let's actually I kind of want to go back and understand this. It seems like a typical example. Okay, so this woman was accused of okay. Okay, so misuse of statistics is okay. Okay, so this was the initial calculation, right? Okay, I see. Okay, so they kind of flipped it around. Okay. Okay, sure. Okay, so this is alright, this is cool. So this is always okay, so this is conjunction fallacy, right? I think it's quite conjunction fallacy is this thing. base rate fallacy is decision making error in which information rate of occurrence is ignored. Okay. Okay, I see. Okay, confidence intervals. Are we required to do t-tests? Okay, yeah, so I require, is this a Z test? Sounds like a Z test. No, no t-test. Okay, that's great. Thanks. Z test. Okay, sure. So, um, yeah. Okay, hypothesis testing. So, okay, wait, did I skip? Oh no, this is still the same chapter. Blah blah blah, blah blah blah, blah blah blah, blah blah blah. Association and no association. Okay, what kind of hypothesis tests are we tested on? I think the best way is to look at the chapters. So, which are possibilities? Number of hits obtained in 3 independent tosses. I mean, this is just math, I suppose. It was an event and an outcome. Sample space 30 days. A is the first 10 days. B is the first day. A is an event. Oh, okay. Event is a sub collection, right? Event is a sub collection. B is an element, so it's an outcome. Outcomes are events. Okay, yeah. So this is just testing on the word event and outcome, testing our knowledge of that phrasing. Okay, mutually exclusive and independent. A football match is played blah blah 90% wearing red. Among them 80%, so it's okay. Among them not okay, sure. A be an event that is rooting for Singapore and B be an event that is wearing red. Okay, so they are clearly not mutually exclusive, right? Because yeah, I mean you can be doing both, right? You can be rooting for Singapore and wearing red, so it's not mutually exclusive. And are they independent or not? Independence means that probability of you probability of intersection is the product of the probabilities. Actually, no. I think the best way to think about it is probability of you wearing red is equals to the probability of you wearing red given you're supporting Singapore. So in this case, I think it should be independent, right? Because it's 80 and 80. That's my intuition. correct? Yeah, okay, yeah, that's good. So both are 80 because yeah, yeah, okay, that's great. Okay, E and F. uh, E and F are both non-zero. If they are mutually exclusive, they cannot be independent. If they are mutually exclusive, both the probabilities will be zero, right? So technically, wait, what? Oh, okay. Okay, I see, I see. Oh, okay, that makes sense. Yeah, okay, that makes sense. If E and F are independent, then they cannot be mutually exclusive. If they are independent, that implies that the probability of both could be zero. No? Why is this? Hello, Karen. Welcome to the stream. Are you taking GEA too? Why is this funny? I'm in pain. Okay, so why is if they're independent, why is it non-zero? Hi, hi Nicholas, yup. Welcome to the stream. Thank you, thank you. Why is this inequality sign here? It's so weird. Uh, yeah, this kind of weird. Why is it? Non-zero. I'm gonna ask ChatGPT. Does independent events mean P A intersect B not equals 0? Oh, welcome, welcome. Choose one only. No, I'm choosing GEA1000. I'm taking GEA1000. Why is this? Oh, it's because it's non-zero here. That's why they say it's here. Hello, Aiden Tan. Welcome to the stream. Nice to hear that you like the streams. This is really just me trying to keep myself entertained so I continue studying and not like get distracted. But yeah, thanks for helping. I don't remember helping you for GA, did I? I mean this, unless you count this stream, but it's really just me going through the stuff. Hello. Thank you, DM. Welcome to the stream. Okay, so if P plus P of probability of E and F are oh, I see. If E and F are greater than 1, they cannot be mutually exclusive. Why is that so? Oh yeah, because they'll fill up the whole sample space, right? And you get it's too many things, right? Too many things. With less than equals to 1, they must be mutually exclusive. Not true. Not true. They could be. Actually, no. Wait. Right. It's false. Right. It's false. It's false because if they are less than 1, if they're less than 1, then yeah, I guess this is a good example. Okay, sure. So let's see. Okay, let's just do one more GA question. Let me. I'll need to print my cheat sheet soon, but I'm going to study some of ST2334 also. Yeah. I'm going to study some of ST2334 because that's on Tuesday and kind of stressed for that. A random sample is taken from population of 10,000 people of age 50. Blah blah blah. Confidence interval. Confidence always contains sample mean weight. I think that's true. If samples are collected same size, are collected using the same sampling method, about 5% of the confidence intervals will not contain the population mean weight. I don't know, but that sounds true. SJPO in a month, any tips? I like Morin, right? I like the Morin book. Morin is great. Yeah. Well, it might be a bit of an overkill for Morin for SJPO, to be honest, but I think a lot of physics comes from understanding things. Yeah, Morin is a bit too hard for SJPO, but I wouldn't say that. I think Morin is good for explanations, right? And if you understand things, if you understand physics from a conceptual point of view, then there really isn't any difference between like SJPO and SPHO or even IPHO level. Like, I'll say that if your goal is just SJPO alone, then maybe just grinding through the questions will help. But if your goal is to understand physics better in the long run, to go further, then reading textbooks that explain well would be great. I would jump from SJPO mechanics to Morin slowly. Wait, I really think that I think bouncing around with a few resources online, like for physics, I really enjoyed Walter Lewis lectures. Watching the MIT lectures, they're quite good. Yeah, I think the key thing about being good at physics in competitions is really having a strong foundation for each of the concepts. So I think I really don't think anyone will be unprepared to read Morin, to be honest. I mean, I could be wrong, but I think if you read Morin and you don't understand something, like you go to other resources to try to patch it up. But Morin is actually quite a good explainer in general, quite a good source of conceptual understanding. So yeah, I genuinely don't. It's kind of one of those situations where you should jump for the moon, but if you miss, you land among the stars, right? So even if you read Morin and you don't understand Morin fully, but you'll still get some stuff out of it. And yeah, so personally, that's how I study. Never really thought of it as studying for SJPO specifically. Always just thought of it as just studying physics in general. Yeah, sorry it's been a while since I touched physics, but I do want to make more physics videos. Just that kind of been busy these days with school, as you can tell, studying very boring stuff like these statistics. Yeah, no worries. Do let me know what kind of topics you love to see. Yeah, so 99% confidence interval and mean height is this thing, constructed using a sample of 100 students. Under the same sample, a plausible 95. Okay, so it's just going to be a smaller interval, right? So clearly the answer should be yeah, it should be B, right? Nothing else. Yeah, it's B. Okay. Okay, I'm tired of GA. What else is there? A p-value. I think if I study a bit of stats, it'll probably cover GA stuff also. Is this what question is this? No, this is the wrong course. GA. Okay, so there are two sample papers, right, for ST2334. Can't remember if I can find them. I'm gonna black out my screen in case because I want to get my questions. ST2334. Okay. Oh, I think I saved it under my downloads. ST2334. Ah, yes, I found it. Sample paper 1, final sample paper 2. With solutions. Okay, I'm gonna go through. Yeah, okay, I'm gonna unblank my screen now. Nice canvas profile picture. Thank you, thank you. It's such a. Okay, so final sample paper 2. Okay, so I'm gonna go through. Let's go through sample paper 2 for now. Okay, so I'm gonna start from the back because the first few questions are a bit too not that worth doing. Okay, so assume the survival time for a patient can teach you F statistic. Right, I need to study that too actually. Yeah, actually I'm kind of concerned about that. I need to study that. Let's see if there's a question that comes across it. That goes over it. Yeah. Assume that survival time exponential distribution average survival time of 4 years. So if such a patient has survived for 4 years, what's the probability they can survive for another 4 years? Right, so the exponential distribution is something like there's this memoryless property, right? So I'm gonna guess it's A. Linear regression with multiple regressors under 4 LSA. Wow, I do not know what those big fancy words mean actually. Are they tested in ST2334? I'm kind of screwed if they are. Right, so yeah, the answer is e to the minus 1 because this is an exponential distribution. Oh. Okay. Let's see this. There's x and y independent random variables which must be correct. Intuitively, A seems to be true. Okay, see you. All the best for your exams too. Mutually exclusive is definitely false, right? Because both of them can. So I'm gonna choose A. Thank you, you too. And C. Now question is B. Actually, I have a feeling that B is actually not independent. B is actually false, right? Let's see. Yeah, okay, I'm correct. A and C. There's no answers, unfortunately, but my intuition is that if I picked a certain value of X and that choice was independent, like that choice was random in some sense, then yeah, I really need some formality around this. I don't know what I'm doing. But my intuition just tells me no. Yeah, my intuition is like, if you pick an X, then the probability of x minus 1, the probability of x minus 1 and x plus 1, if x is, let's say you pick 5, right, then 4 and 6, the probability of 4 and 6 happening. Oh, okay, wait. No. I think you can kind of phrase this in another way. So if we call this A and B, if A and B are independent, you know what? I'm gonna ask ChatGPT. This is not great. If x and y are independent, are x plus y and x minus y independent? Okay, this is classic apparently. Oh, right. Knowing one tells you the distribution of the other. Yeah, right. Knowing one of these, it can tell you knowing one of these. Okay, so yeah, if you know okay, so if you know x plus y is 1, then you know, yeah, okay, that makes sense. That actually makes a lot of sense, yeah. What's the absolute value of the computed statistic? Okay, I think this one for this I need a GC, a graphing calculator. Let me get it from my bag. Okay, so before and after at 3 industrial plants, testing the alternate hypothesis that the safety program reduces average weekly losses of work hours due to accidents at a 5% significance level. Right, I do not know what the statistic is here. I'm gonna check the answer. And what kind of statistic is this? Let's ask ChatGPT. Oh, it's called a paired t-test. Right, that kind of makes sense. Yeah, okay, that kind of makes sense. Let's see if there is in the calculator. Statistics, calculation. Is this 2 variable or is it 1 variable statistic? I think it's 1 variable. Nah, I'm gonna have to ask the GC. Paired sample, paired t-test. TI-84. Okay, enter the before data and the after data. Okay, so I need to make a list. How do I... how do I edit a list? Right, I can edit a list there. Okay, I think I'll enter the data here. So 45 minus, so the difference is 9. 9, that's 5 and 4. And so now I go to statistics, calculate. Is it one variable or two variable stats? Oh, it's two variable stats. X list and Y list. No, not really. I'm gonna watch one of these videos. Okay, they do this. Oh, it's the test. Stats test 2. And okay, so data mu0. Oh, mu0 is the null hypothesis, I think. Okay. Yeah, okay, I get the same answer. I think that's good. Okay, another one of these. Actually, you know what? I'm going to actually, I think this one is not sufficient information. Yeah. I'm going to try to look for questions which involve more of such calculations. Yeah, what is the value of B such that this 95% confidence interval I think this is a Z, going to be a Z test. I don't know why they gave us T values, but let's just use the T values they were given then. Hi SSNX, welcome to the stream. Okay, yeah, so I don't know why they give us T values actually. I'm gonna check the answer. Do they ever use the values? They actually do use the T values. That's mildly surprising. Yeah, that's kind of surprising actually. Hi Yit Everyday Gaming, welcome to the stream. I'm studying for my university exam. Save me. Okay, I guess I can just kind of try to memorize this formula. Actually, what's going on here? T of 3. 3 is the number of, I suppose it's from 4 minus 1. S is from the, yeah, S is from this one. We got S by taking, yeah, okay, that's quite clear. No, is it 1 plus 1 plus 9? Oh, no, because we need to 1 plus 1 plus 9 plus 1, that's 12. 12 divided by 4, 12 divided by 3. Oh, but in sample, okay, I really need to revise this actually. This is quite bad. This is actually quite bad. files, lecture notes. I need to revise this chapter. Don't know what's going on. Oh, okay, here we are. Okay, this is great. S squared is this, right? Okay, yeah, this is what, this is how we got the answer, n minus 1, right? That's how we got S squared. You divide by square root n. Why is it a t statistic? I really don't understand. If z and u are independent, okay, okay, let's see this example. I think this example might be instructive. Hi, DSD, Quest Estas Chando Lihasa, and welcome, attempt number 1. Yo, it's TCH. Hello. Sorry, I'm streaming because I need some motivation to study. And this is quite a dry topic, so if I don't stream, I'll lose motivation quickly. Okay, find C such that P S squared bigger than C. Is this thing? Huh. Okay, variance is 4. So from this we know that 5/4, okay. Probability of this. Actually, I need to learn how to do that on GC, right? Statistics, calculator, test. Okay, I see a chi-squared test, but is it a goodness of fit? No, it's not a goodness of fit. I actually don't know how to calculate this. I'm kind of screwed for this mod. Stat menu. Oh, it's under distribution, right? It's under distribution. Okay. Chi-squared CDF. And in this case, I'll be putting in. Okay, they do this thing. I think I'll be putting in minus infinity. How do I do that? Yeah, I really don't know. Let me check. Lower bound. Okay, yeah, lower bound we can usually put a very big number. Okay, let's try that. So the lower I'll put. No, actually I want something upper, right? The probability of this being bigger than that is. I'll try it out. So let's say the lower is 0.05. No, actually no, I want inverse CDF. Right, so I have a chi-squared, is there a chi-squared inverse? There really isn't. Chi-squared CDF. No, I want to calculate inverse. Option 7 is really not. Option 7, no, it really isn't. Let me just I don't have the inverse though. Kind of confused. Inverse T, inverse. Is my calculator bad? TI-84 doesn't have inverse chi-squared. Oh. FCDF. Okay, let's see if this the math solver, numeric solver. Oh, okay, that's interesting. I'm seeing this right now. Okay, 0 equals to. Wow, I'm actually learning a lot of things from my calculator. Yeah, this is quite interesting. FCDF. It's a chi-squared CDF from okay, so back to the question. I'm trying to solve for lower will be x, right? Lower will be x. Upper will be 10 to the 9. And degrees of freedom over here is 5. Paste. Press OK. Solve. Okay, should be 0.05. 0.05. Okay, solve. Oh, it's taking very long. Oh, I got a number back, but it's not correct though. That's unfortunate. Okay, this is still the same value. How do I do this? No, I'm not getting the correct value. Oh wait, I did get the correct value. It's just I did get the correct value. It's just I kind of misread it. Yeah, okay, I did get 11.07. Okay, great. I know how to use the GC. Um, yeah, okay, sure. I'm not gonna get this in the exam for sure. Oh well. Is S squared, if S squared is a sample, it's a variance of a random sample of size n, then this statistic is a chi-squared distribution with n minus 1 degrees of freedom. Okay. Okay, let's go back to that question. So this is a thing, but where does t come from? Where does this question use t? Ideally, I would like to find out about that. Central limit theorem. Okay, yeah, so where do they mention t distribution here? Random variable has the same, okay, blah blah. Okay. Chi-squared is meant to be... This is what chi-squared means, is it? What does this mean? Uh, okay, they're using radiant here, but okay. Oh yeah, okay, t distribution. Okay, they say later chapters. Okay, so t distribution, they said that oh, okay, okay, I see. So hello, hello. I'm studying ST live streaming. Oh, You study ready for GA?
No. I stopped studying since like morning.
Study whatever I can already.
Yeah. Tomorrow,
Martin!
1 p.m. right?
Yeah, 1 p.m.
Okay, I see how it goes. Okay, I understand now. So if we have this, when you calculate the s squared, the s thing here is yeah, okay, and then we get the t values. Let's go see the next chapter. Estimation. Okay, yeah, this is what we want, right? What is alpha? Oh, alpha is this one, right? Alpha over 2. Alpha is the confidence level. 1 minus alpha is the confidence level. Okay, so yeah, okay, so I think I understand this.
Hey, fish.
Yeah,
Later you go down.
can.
Just went down, bro. Cooking long.
Can. No worries.
What's this? Online
Stats. No, this is ST2334, a different mod, but
Oh, you study for both?
yeah, because both are stats.
Oh, shit.
一举两得. Um, okay, so back to this lock in. Yeah, okay, so what does this mean actually? Wait, this is clearly true, right? Wait, shit, it's false. Why is it false? Wait, isn't this clearly true? Oh, if it's discrete, it's true. But it's not necessarily true if y is continuous. Huh. Wait, why is that so? Wait, why is that so? It's true if it's a discrete random vector. But it's not necessarily true if... Wait, I really don't understand why. Let me ask ChatGPT. Oh. Huh? What? Why? Uh... Oh, okay, right. That makes a lot of sense, yeah. Because if it's uniform, then your probability could be very high, right? Okay, I think this is just applying the formula. So using this, calculate the covariance, and just do the other way. Okay, I think I want to go for the distribution questions. I'm not that concerned about the probability questions, but more concerned about the distribution questions. Um, Covariance means that covariance independent means that the things are how do we know this is independent though? By identifying that they are independent. How do you know it's independent? Let me ask. All in. Welcome, Ashton Ng. Studying stats so I can be better at playing QF. Okay, this is the definition of independence, right? No, if it's independent, then it will be this. Wow, that seems really complicated. I'm really confused. Oh, if it's separable, then it's independent. That's nice. That's easy. Well, the long way would be to... Why is that so? Right. Actually, this makes a lot of sense, right? If it's... if it's this, then yeah, that makes a lot of sense. Factor the joint thing, you get this. So if you integrate the marginal stuff, and check that they are both valid PDFs. Okay, yeah, I'm convinced. Okay, this one, compute the variance of x. Okay, let's check this. Let's try this. Assume a random variables. Which ones must be correct? Okay, I mean, clearly A feels false. No, A is true. I thought we established that those are x plus y and x minus y are not independent. Covariance can be expanded as such, which will be reduced to okay, I can get that. Oh, wait, that's actually an interesting thing. So if the variances are the same, that will actually imply that okay, wait, that's actually interesting. I'm gonna go back and edit this question. What if variance x equals to variance y? It feels like the answer will be different. Usually not. I really don't have good intuition for this though. Zero covariance does not indicate. Oh. Wait, what? Oh, so covariance equals to 0. Oh, okay, I'm mixing a few things up here. Uh, just because the covariance is 0 doesn't mean that it's independent. I need to really improve my stats by a lot. It's kind of too late, right? Um, I think it's C. Yeah, C. Okay, uh, yeah. Sorry, been a bit tired. T is the minimum of all these, and this is all following the exponential distribution. The expectation that okay. Oh, that's interesting. Okay, if both are Poisson, you add them up. Okay, so Poisson, okay. Think that okay, I'm going to okay, let's take a look at this table. If it's a normal population or any population, blah blah. If it's any population, then you need the n to be large, right? And you follow z. But if okay, so the difference is when this one is unknown. Ah, okay, right. So the difference is when it's unknown. Okay, so let's consider this example. So we estimate, right? What's the maximum error of our estimate? Right, this is okay, so let's say we have this. So this will be standard deviation is known, so it'll be inverse normal. And the area will be center. Select a random sample of 50 users. %, right? So 0.99. Oh, maximum error of estimate is something entirely else. But how do we get that? Oh, okay, okay. Z 0.05 means the tail end. Okay, okay, I'm a bit confused about all the paired tests. So like over here, which of the following is an unbiased estimator for sigma squared? Okay, so known and unequal variances, when they're both sigma, they are not estimated from the sample. In that case, either they're both normal or samples are large. In that case, the statistic is Z, and you do this thing, right? Yeah, okay. And then you win, right? If you have known and unequal variances, then this is summary. So an example would be this. So no, this is known as equivariance. Hey, thank you, bro. Thank you. I pay you. Kind of tired. Hey, some tips for PHO. Which level are you competing at? Is it like international, uh, or local Singapore, or sorry, I'm a bit sick, but I'll try my best. Just let me know. I'll genuinely, most of the time I'll just say read Morin, but depending on the specific topic I can recommend more specific resources. Basic to advanced. I think start by watching MIT 8 the 801, 802 series. I genuinely, that's how I started a lot of intuition. Yeah, get the intuition first, then learn multivariate calculus from Khan Academy. That's genuinely, I think knowing multivariate calculus makes a huge difference because a lot of things are formulated in terms of vector fields. Like force is a vector field, right? Electric field, those kind of things, they're all vector fields. So learning multivariate calculus is definitely a big plus. And when you feel ready, you can start reading Morin. Yeah, Morin is a great textbook the for both the classical mechanics and the Newtonian mechanics one and the electromagnetism one. I think both are good. So yeah, hope that helps. And of course, doing a lot of problems. I think that's something I kind of under. I did too little problems. I definitely should have done more problems, but yeah, doing problems is the hard, but it's a discipline thing to do actually. Is you need a lot of discipline to drill through the problem set, but it's how you really improve. But having a strong intuition is good in general too. Okay, so speaking of doing problems, I should probably do a few more problems before I go to sleep. Okay, wait, I still don't really understand this entire thing. There is known and equal variance. Known and equal variance, large with unknown. Oh, so this is if unknown, you don't know the variances, but sample size is large. In that case, if you do not know the variance, the natural thing to do would be to calculate the sample variance, right? Using this, or rather the unbiased estimate of the sample variance. And then it isn't really too far off, right? Yeah, it's around the same. So small with equal variances. So I suppose you know, no, you do not know the population variances, but you know they're the same. In which case, you want a pooled estimator. And why do you want a pooled estimator? Well, to be honest, a pooled estimator is really okay. So the pooled estimator is the one that is a bit confusing. But I think that tells me that the answer to this is B? No, A and D. Oh. Oh, I see. Okay, I think I understand. Degrees of freedom. So it's equal variances that is when it's pooled, right? And if it's small then it's T, if it's large then it's Z. Same deal for paired data, just that okay, I think I roughly understand this. I don't know, I hope it's enough. I hope it's enough. I don't really know how to do this question. Oh, I think I do. So Z will follow, is X bar will be N 2 comma 4 out of 25. Then we divide by this. The 4 out of 25 will disappear, become 1. And it'll be N, so Z will follow N of 4 comma 1, sorry, 5 comma 1, and if it's 5 comma 1 then Z will be there, and for it to lie within this region. I think the answer will be A. Yeah, we are correct. Okay, yeah, that's true, right? Okay. That took me very long, but yeah, I'll probably do one last question. Kind of tired, honestly. Okay, 2 more questions. Okay, 3 more questions. This sum roughly bigger than 5.1, right? If this sum is bigger than 5.1, it means that the average is supposed to be bigger than 5.1. And if we know the mean and the variance, the probability that that is bigger than 5.1 be the probability that that thing with 5 comma 2 squared out of 100 is bigger than 5.1. If you subtract it out, it will be the probability that's 0. Probably the normal that thing bigger than 5.1. Do a offset, probably at 0, 1 bigger than 0.1, but you must divide 0.1 by must divide by 2 out of 10. 0.2, 0.1 divided by 0.2, that gives you half. 0.5, So I think it's 1 minus this thing. No, it's 1 minus this thing. Yeah, okay, I got that. Let's do this one. Consider a z-test for this based on this. Turns out that x bar is actually this. So there's a sample. P-value for this is half of that for the two-sided. The p-value for one-sided test. Okay, so z-test with h bar equals 0. So the p-value is the p-value for okay, 95% we're using this one, right? Z of so we just basically we take $200 plus minus this number times sigma over square root n. Yeah. Okay, so we take the differences. Okay, I think I'm gonna call it a night for today. Studied quite a lot. Yeah. See you.